Hello class, good morning. Am I audible? Hello, Ayush Raj, Deepak?
Yeah.
Okay, good morning. So let's start the next topic. Anybody will tell me what we have discussed in the previous two lectures? Yes, Miraj Siddiqui, Santosh Tripathi. What we have completed so far in the previous two lectures? Which objective is complete? Avish Chaudhary, Atul Raj. No one was attentive. Is the screen visible to all of you?
Yes, sir.
Now see, in the previous two lectures, let me continue. No one is responding. In the previous lecture, this is the presentation which we have completed, and here we have discussed about the fundamentals, about the algorithms, their characteristic, how to write the algorithm, what are the standard ways, what are the variations possible, and how to find out the space complexity of any algorithm. So this is what we have completed, and now we are moving towards the asymptotic notations, that is relative to the complexity representation. Okay, so let's go for this. Okay, asymptotic notations. The term asymptotic notation is actually asymptotic, that is a kind of matching in the behavior, okay, similarity, and that is actually concerned with the growth of the function, okay, how slowly or how fastly that can we move it? Okay, so why it is coming up like this today? Okay, why the asymptotic analysis, why it is important to study, and what is the utility of it in algorithm subject for the complexity representation. So here I try to summarize some important points about it. For asymptotic analysis, actually it is for the purpose of finding the complexity of any algorithm. So what we do actually when we have to find out the time complexity, now we have switched over for the time complexity, okay, space complexity is already complete. For finding the time complexity of any algorithm, actually we find a function for. A function means a function like in mathematics you have any expressions like x plus y. Here in terms of n you will be having the particular function, and that function will be for the purpose of finding the total number of operations or number of steps in the form of variable n. N, that is a variable which is an intrinsic characteristic that is will be input by the user at the running time. So a function in terms of n is to be find out whenever we have to find out the time complexity. So the focus towards finding the function, and what the function is for total number of steps which will execute for completing the running of code. In the previous presentation, you have seen where we have discussed that the running time is proportional to the total number of operations, and where we have reduced that towards the total number of the steps. Okay, instead of actually looking forward that which particular operation takes how much time, the number of steps proportionality exists there for the time taken by the execution of the code. Okay, so the function is to be framed for counting the total number of the steps in particular given algorithm, or we can say for total number of key operations. These are the two ways we can focus for. You will see slowly in the different examples. Total number of key operations. Operations which take more time comparative to other operations. This point is also discussed while we have discussed for that the running time is proportional to the total number of the steps, where we have seen the different operations: arithmetic, logical, conditional, decision making, and all. So function representing the number of steps or the number of comparison operations may have many terms. You will get the function maybe of this type or of some other type. For example, n cube plus 3 or n cube plus n square plus 7, 90, whatever. You may have a function of such kind. So how the asymptotic notations are here in the picture. After getting the function, we can take the help of the asymptotic notation to represent the complexity in a single standard function form. So what is written over here? Asymptotic notations provide method for representing such functions, the bigger functions, more than one terms when we have, in the form of standard functions of single term only. So that helps to get know easily the scalability possibility of the algorithm with reference to the size of input increase or decrease. Okay, so asymptotic notations are important to present the complexity in standard function form. Okay, so let's proceed. Today this is not coming out. Okay, let me share again so that you should be able to see it completely. Why this is coming today? Maybe now. Oh, we are not able to remove it. Okay.
You can click on.
Okay. I was clicking and doing everything. Now it is okay. Okay. I have taken some other algorithm, L3. So asymptotic notations are important in that sense for easily understandable form of the function for representing the complexity. So analyzing the algorithm, this particular slide we have discussed earlier, and I have given the reference and I have updated this statement so that you don't remain in the confusion for that there was equality in the previous slide. Better to use the proportional. Okay, because in algorithm analysis we are not actually absolute value looking for representing the complexity. We are not finding the actual value of the running time. We are finding a function which represents the tendency of that algorithm in terms of change in time with change in the input size. Okay, so this this statement is very important to be clear about, right? So this I have given you the reference in the beginning. Now we will take the example in the beginning itself and then moving ahead about the different asymptotic notations. Example for constant time complexity. For the constant complexity, whether it is space or time, we have already discussed, we have this notation, and it is also a asymptotic notation which is big O. We have other two asymptotic notations also. So it's a general understanding about the constant time or constant space requirement for it. Here we are talking about today for time complexity, calculating using big O notation. Okay, taking the example in the beginning, considering like you have uh, the discussion about it in data structure, and I know myself I discussed in TOC before, but even then we will repeat, but now it will give you the fast understanding when we proceed with the example. So this particular pseudo code is very small one with 2 lines only. The algorithm is sum. Okay, here it is not represented in a very standard form like I should have written here the algo and that. Okay, directly it is the name of the algorithm, its parameters, and simply returning this. Okay, we have taken such type of the example for the space complexity. Also, there was a big expression in terms of 3 variables A, B, C, if you remember, okay, in the previous presentation. So to find out the time complexity, we have to see how many steps we'll execute. Now what we are saying here takes this particular algorithm takes 2 unit of time. 2 unit of time is the fixed one. It's not changing at all, and we can say that the complexity is of order 1 because of the constant. Now we will discuss how the 2 unit of time. Now you can easily relate it with the number of statements. So 1 unit of time for arithmetic operation. There is a arithmetic operation for addition of 2 variables. Okay. And 1 unit of time is for returning that calculated value of addition. So 2 unit of time, it is very much fixed. There is no possibility for change in time requirement for any other thing. So the time complexity is constant, and we can say the time complexity is of order 1. Okay. So very simple. And here are some more descriptions which I already given you. So some kind of this representation you may find somewhere. The cost is equal to 2 for statement this itself. Okay. The execution statement is this only, where 1 unit of time is for this and 1 unit of time for this one. Okay. So this is not actually executing, it's simply the definition for name of and the parameter information, right? So elaborated expression, I think it's simple. So the observation is only number of steps count is important, as time of execution will be directly proportional to the total steps count. Okay. Now we will go according to the Sartaj and Sahli for easy finding out the total number of the steps, and according on the basis of the total number of the steps we can easily represent the complexity. And currently we will be talking about the big O notation only. What is this big O, how it works, and what are the relations with other asymptotic, we will talk later. Just to have the understanding for this particular way for finding the step count in a tabular form, which is easy and interesting and comfortable for everyone to represent the complexity using this method. Okay, suppose you are given this particular algorithm. Okay, here the statements. Okay, so you can give the attention towards it. What are these steps? Before, let's see the table format. So you have the statements, then you have the total number of steps per execution. At any time of execution, how many steps will execute, and frequency total, how many times it will, the particular statement will execute total. Okay, frequency, how many times, and then accordingly total number of these steps. Okay, it is this into this. Okay, now see, for the execution for this particular statement, the count is 0. You have to give the attention to the statements where some operation is taking place within the functional body of the function. Here the functional body. Okay, active statements within this. This is a opening braces, so will be given the count 0 for execution, right? So let's talk about the first column before these two. Okay, now if the statement this comes, if n, okay, it is if n is true, n is false, or n is equal to 1. If there is a conditional statement, of course at a time it is going to execute for one time. Okay, then you have the statement return r sum. This statement count is also given as 1 here. Now in total, how many times this statement will execute, that we will see in the frequency case. Next one is your return the list. This will also execute 1 time, and the count for this is 0. Okay, now we have to look forward for the frequency, how many times it will execute. You have to give the attention for the parameter n, which is changing and controlling the number of times of execution of different statements. Like here you see there is a conditional statement. Okay, I think it's very much obvious. It is having a one array named list, data type float, and a variable n for the size of this array list. Okay. So if n is not 0, okay, the meaning of this, when n is not equal to 0, when n is not equal to 0, the meaning of this is this. Okay, if it is not 0, it is going to this particular step. Okay, and in this step you are finding the recursion process. It is calling to itself with the change in the value of n with 1, decreasing the value by 1. Okay, so how many times it will execute in total? You can take an example. Let's say n is equal to 3. Let's say n is equal to 3. Do you find that this statement will execute 3 times? It will execute for the value 3. Yes. Okay. Then in the next time the value will be 2. Of course the condition will be true. It will execute for 2. Then again the value will become 1. It will execute for 1. Then the value will become 0. It will not execute for 0. So the number of execution is 3 when the n is equal to 3. Means the number of times of execution of this statement is n. Okay, I have described this one first and this later. Here it will execute for n plus 1 time, because other than for these 3, it will check the condition for 0 also. So it will execute for one more time while it will not go within the loop or after the if condition check for the value 0. But it will execute for 0 also, this if statement, so n plus 1 times. Okay. So in this way, the total number of steps of execution, this into this 0, this into this 0, okay, and this is 1 into n plus 1 is this and this, and in this way you can count these total coming up to n plus 2. Now the complexity of this will be decided with the help of the leading term in this particular expression. And you can say considering the term which is having the highest power of n, and it is only this 2n. The coefficient is not a matter or not going to affect the growth of the function. The growth of this particular function will be controlled with the n only. Rest will be working like a constant addition value. So the complexity of this can be easily told as of order n after representing this much. Okay, so in this way this method is easy, and you have to have the clarity about the total number of times execution of each step. Okay, another example in front of you for the matrix addition. Okay, so here also you can easily find out the execution, number of steps per execution, the frequency, and the total steps, where the statements are given here in this particular. Okay, for this one of course it is 0, for then next one is 0. Okay, not a problem, very easily understandable. For this also you are giving the attention towards the arithmetic logical operations statements. Okay, and for loop is given here to be run with one time. This is also given one time. How it is one time? You just give attention, think about, I will explain if you will not understand. And for this also it is executing one time, and this bracket is like taking, it's like taking no time. Okay, it's a part of a process for writing the code, but we are giving the values of time to the arithmetic logical operations, loop, etc., conditional statements. Okay, so how this is given for value 1, and here it is said the number of times it will execute rows plus 1. How many times it will execute rows plus 1? it is very much obvious. You will consider, okay, it's a one for loop, okay, so one time it will execute. But for the total frequency, you have to see how many times it can run. Because it is from 0 to less than row, then it is going to give the false value when the value will be equal to row. So it is going to run from 0 to row. Whatever is the value, let's say the value is, okay, take the smaller value, value is 2. So it is going to run for 0, for 1 and for 2. Because it will be giving the false value for this. So the number of times is 3, 0 to 2, while the value of row is 2. So to make it 3, you are here with the rows plus 1. Okay, it's an inner loop, will be affected by the number of times the outer loop will execute. So you can consider it a standard way for calculating the execution of inner loop when it is controlled with the outer loop. Like this, number of times the outer loop is the value of the variable rows, and then for internal one, like you have here the rows plus 1, it will run for this much of times. Okay, so in this way the total number of times is here. Now this particular statement will run how many times rows plus columns, which can be easily calculated with the help of values. Let's say for the row the value is 2 and the for columns the value is also 2. It will run for 4 times. You can easily calculate it with the help of reducing the values and applying the value of I equal to 0, then 1 and then 2, and similarly for j. So number of times this statement will execute is this one, and accordingly the frequency is this one. It comes same because here you have the values 1 1. So it's same 0 0 0 rows plus 1, this multiplied with 1, this all multiplied with the 1, this all multiplied with the 1. So the complexity is this one. Now depending on the values, let's say the variable n is deciding about the row and the value m is deciding for the column, the complexity is like here of order mn. So in this case you can represent the complexity of order mn. If both are having the value same, then it will be automatically coming like n square. Okay, so in this way the complexity, which complexity? The time complexity, okay. So this is the tabular easy method for representing the time complexity this way. Yes,
What is S/E?
hello,
What is S/E?
where, what are you saying?
Frequency.
S,
S/E क्या है?
which statement?
फ्रीक्वेंसी के बगल में.
This is for the frequency, how many times a particular statement will execute in total.
फ्रीक्वेंसी के लेफ्ट में S/E.
This is steps per execution.
Oh.
Number of steps per execution. एक बार execute होता है तो कितने step execute हो रहे हैं?
Oh.
Okay, steps per execution. I told here about this here, steps per execution. Okay, steps per execution यही mention करना ठीक है.
Hello, ma'am.
Steps per execution.
Hello.
Okay.
Hello.
Okay. Yes, student.
Yes.
Okay. The volume is very low.
Hello,
Okay.
ma'am.
So in this way, you have seen easy way for representing the complexity. You can try for other examples also. And if you will have some doubt, you can ask. We will go on taking different examples to cover all the possibilities of different types of the operations. Okay. So algorithm analysis, another example, which is here in a different way, little bit. Tabular is not made, but actually counting the total number of these steps. Okay, so you may follow like this also. This is the algorithm for finding the mean. We are taking very easy examples, and these gives the strong base for any algorithm. Okay, so it's not a problem. and you are finding this assignment statement, you are finding this for loop here. Okay, for finding the min, the logic I don't think is needed to be discussed now. We have seen that code earlier also. And if you are finding the another element smaller than that, that the value of m is changing. Okay, with that smaller value, that is finally m variable is coming up with the minimum value. Okay, for finding the running time, the number of primitive operations, or you can say the number of steps executed before the completion of this completion of the execution, or you say before termination. Total number of the steps count we may represent like Tn. Okay, the time required for execution in the form of n. So in this way also, so I'm just moving you ahead towards writing the expression for the time requirement. Okay, the time requirement is proportional to the number of steps, and here in mathematical, to represent the complexity in asymptotic notation, we can write down here this Tn equal to. Okay, because finally it is going to come up with the asymptotic notation where it is not exactly the equality, it's just a form of the function which represents the growth, right? So that's why proportional or equality, ये point आपको clear होना चाहिए. So Tn, so first step के लिए count 1 है. Okay, first step this one. Okay, for this the count is 1, assignment operation hai. Then for the loop, okay, is going to run for n times. How it is run n times? Are you clear? 2 to n, 2 to n, value 2, let's say the value of n is 4. Okay, so it's going to run for 2, it's going to run for 3, it's going to run for 4. For loop n times, अभी तो 3 टाइम्स हुआ. 5 किस लिए आता है? जब कंडीशन फेल हो जाती है, पर ये एग्जीक्यूट तो करता है ना. ओके, सो द टाइम्स इज 1 2 3 4, सो n. ओके, n. And for the conditional statement, if this is going to run n minus times, for this also you can take an example of the array, and then you will see that it is going to run for n minus 1 times. Okay, because it is n, so अंदर तो वो जाएगा ही नहीं, तो obviously n minus 1 होगा. Okay, it will run for conditional check additionally, right? And then you have another assignment statement which will also execute n minus 1 times, because it is the it is within this loop. Okay, so in this way the total count is coming up 3n minus 1. In case of asymptotic notation representation, what is the complexity? Yes, any one of you? What is the complexity?
O of n.
N.
What is the complexity? I will start noting down the names, because last time also in TOC, you know very well, I have given at the last time after finalizing the marks to look upon those list of the students and accordingly upgraded looking their performance for assignment class test. That includes the class performance also. Okay. So what is the complexity?
N, ma'am. O
An
of
order
n.
of n.
Of order of n. Complexity should not be told like n. It should be having the term before that, order of. Okay, order of n. Why not exactly n? Because the complexity will not be like the 4, 5 or 6. It's of order n, means the rate of growth is whatever is the rate of growth of n. In the same manner, the rate of growth will be there for the time requirement for the algorithm with the change in the value of n. That is why it is told it is of order n, not n exactly. Okay, so order of rate of growth, I think this concept must be clear to you. So be in practice to have the explanation for or telling the complexity in this form. And I have already told you the leading term of the formula is to be concentrated, because that controls the rate of growth. The rest of the things works like a constant thing. So expresses the asymptotic behavior of the algorithm. What? When you consider only the leading term. So in this way, you have, I think, now idea after the space complexity calculation, the time complexity calculation. Okay. So now let's go for further discussion in case of looking some standard functions to relate the total count of these steps through a function, then relating that with the standard function. So it is important to see some standard function which are in use for representing the complexity. So algorithm have a primary parameter n that affects the running time most significantly and typically represents the size of the input. Many times I told you, okay, it can be uh, according to the program what size, which size for what. Okay, commonly encountered running times are proportional to the following. You will always find the complexities representation commonly in this form: of order 1, of order log n, of order n, of order n log n, of order n square, of order n cube, of order 2 to the power n. And you call repeatedly, ये बहुत बार बात हो चुकी है, constant, logarithmic, linear time, because it is n, it is linear, and this is logarithmic. Logarithmic, there is a difference actually in n log n. Log n, you will see in the graph later. It is comparatively better. Log n is better than n log n because it is multiplied with the n, so rate of growth will increase. And we want the slowly growth, better consideration for the algorithm. Okay, n square, you can call this a quadratic, and this is cubic, this is exponential. Okay, so in this way you can use these mathematical terms for representing the complexity. The complexity is of quadratic nature, okay, cubic nature, exponential nature in terms of rate of growth of the time requirement with respect to the value change in n, size of data. Okay, so typical running times, more extension for all this, constant running time. Instructions are executed once or a few times, exactly fixed time. It's basically the fixed time, okay, constant time, fixed time. Log n, or this is logarithmic. Now you see here, whenever you will be having a big problem which is solved by cutting the original problem into smaller sizes. So just consider it a key point which will help you further for other discussions when we will discuss about the divide and conquer. So divide and conquer is what? Cutting the original problem in a smaller one. So it's related with the divide and conquer, but does not mean all divide and conquer is going to give you the exactly log n, but you can just have a idea about that when the log and logarithmic complexity can come up. Okay, so by a constant fraction at each step. So the algorithm, whenever you will find such type of method for solving the problem where you solve it by dividing the complete problem into the smaller one, and every next step is of lesser size with some constant fraction. Fraction means maybe the bigger problem is there originally, and then you are dividing it into the two part. What does it mean? You are divided, it's a fraction, half. Every problem has become half. Then further, every part of the problem will become 1/4. So in that way, you will find the complexity of logarithmic nature. Okay, so in this way, you can have a judgment and idea about. In case of linear, you have seen already many examples. A small amount of processing is done on each input element. Okay, it's simply some kind of some data is there, some processing is done. So the processing is directly based upon the size of the data, that is the linear nature. Okay, n log n, you see interesting relation with the type of the problems. A problem is solved by dividing it into smaller problems because it is of logarithmic, and how n is there, solving them independently and combining the solution. When there is no relation in the divided parts for processing, then those type of the problems you may find having the complexity n log n. So you don't need to have a just a rectification for this, just to have the possibility of the complexity guess for the type of the algorithm, but actually it is to be find out, and it is to be actually worked out for finding the function. But even then we should have some idea that where we can have such type of the complexity. Okay, so a quadratic, typical for algorithm that process all pairs of data items. When there is a pair, of course there become a quadratic nature, multiple pairs. Okay, like combination of first data with the second, second with the third. Can you imagine where it can be? Bubble sort याद आ रहा है आपको? You work with the pairs, so maybe you will find the complexity quadratic in that case. We will see, but it's just a sample idea to you that in this way you may think of for such type of the complexities. Okay, cubic processing triples of the data when you have the combination of three sets of the data, or there are the triple nested loops, then you may find the complexity of this and cube nature, and to the power k polynomial nature, to the power exponential. Few exponential algorithms are appropriate. It is not described here. You will see automatically kind of function where you will find the n with some particular higher power. So few exponential algorithms are appropriate for practical use. Simply just told, okay, the time taken is much more because the algorithm is of exponential nature, means with the size of change in the end there is a drastic change in this time requirement, but even then the problem is unsolvable by the other method. So that's why the topic of discussion that polynomial and non-polynomial time. Okay, so polynomial time, non-polynomial time, that is much more time taken. Okay, a non-polynomial solution is not possible. So but we have to solve the problem. Okay, if it is solvable only by the exponential time taken, then it's fine, we have to solve somehow. So in this way you will see this different standard functions for. Now it can be a more better way to have the idea about the rate of growth, that which one is better, which one not. So that you can see with the help of this table with the change in the value of n. For example, initially the value is 1 and then it is made 10, then it is made 100 and then 1000. Okay, then on the basis of that, this is for the constant, some algorithm is the constant, you can better to leave it, constant value is shown here. Just leave it. Let's see for the standard function, it is constant itself, that there is no dependency on n. Okay, independent of n. You have seen the example yesterday. Independent of n. So in that case it is always constant. Okay, always constant, independent of n. So concentrate for this log n, n log n, n square, n cube, and this 2 to the power n. 2 to the power n, you have seen exponential nature. You can see here with the values also exponential nature. First of all, let me talk about this. In case of exponential nature, when the value of n is 1, for 2 to the power n, it is going to give the value 2. Now the algorithm which is solving a problem and having the complexity of 2 to the power n order, then with the value of 10, आपने data size को 1 से 10 किया, you see much more change in the value of 2 to the power n, means exponential growth in the time requirement, much more time. Data में कितना change हुआ? 9 का ही तो change हुआ. 1 था, अब 10 हो गया, 9 numbers increase हो गए. Okay, for processing whatever it is, maybe sorting or searching, whatever it is. Now when the size is changed from 10 to 100, then this much. So you can see the difference. इन दोनों में कितना difference है? Much more difference. 1022 1022 का difference है. तो growth काफी तेजी से बढ़ रही है. Fastly growing. Okay, fast growth. Okay, fast growth. किसमें फास्ट ग्रोथ है? टाइम रिक्वायरमेंट. ओके, सो एक्सपोनेंशियल ग्रोथ बिकॉज ऑफ दिस मच ऑफ चेंज. अब इन दोनों में आप डिफरेंस करिए तो देयर इज ए वेरी हाई वैल्यू. ओके, इन दोनों में आप डिफरेंस करिए हाई वैल्यू, सो एक्सपोनेंशियल ग्रोथ. ओके, नाउ सी द नॉर्मल वन एंड इट्स सिंपल. जो डेटा में चेंज हुआ वही टाइम रिक्वायरमेंट में चेंज है. द फंक्शन इज ऑफ ऑर्डर एंड सो लीनियर. ओके, log n के केस में देखिए, कंपेयर द log n एंड n. नाउ हेयर द डिफरेंस पर अटेंशन रखना है. डिफरेंस से ही आप इनका रिलेटिव ग्रोथ अंडरस्टैंड कर सकते हैं. डिफरेंस इज ऑफ n 9 and here the difference is of whatever it will come 90. Okay, Now see here the difference between these two values. If the complexity is of order log n, then in that case the difference is of only 3.32, where it is 9 in case of n. So which one will be better? The algorithm which will having the complexity log n will be better. And similarly, you can observe the difference between these two values, which be much lesser than this 90. So this is better than this, and similarly log n is better than n log n, because you see first stage पर ही difference को आप observe करिए, the difference is time requirement is changing with the rate of change of 33 value, and here it is 3.32. So log n is considered better than n log n. Okay, and here in case of n square also you can easily compare. If this is which one is better, these earlier one are better than n square. As you are going next forward, these in this direction you will be finding the faster growth, while in the previous one the lesser growth, and it is having the minimum growth rate. This is having the minimum growth rate. Okay, this is having the minimum growth rate. Okay, and this is having the maximum growth rate and is the exponential growth. Okay, exponential, which is automatically you can say the maximum rate of growth. Okay, so it is least preferable until unless we are not able to solve the problem other than this much of complexity algorithm, we will not accept it, we will not use it. Okay, so this is the important thing to discuss about, so that you can have the relatively idea that assist you to decide which algorithm is better. Okay, on the with the help of complexity, right? So most common growth rates are it is more extended with, like in the previous one you have seen a lot of discussion about all this. The similarly is extended with some examples even, which I have told you myself. Okay, so constant time requirement, these are always coming up with the best case because there is no change possibility. And in case of the logarithmic, you have seen the divide and conquer, like binary search will give this type of the complexity. A linear search type of the algorithms will be coming up with this type of the complexity, linear one. In case of divide and conquer algorithms like merge sort and the quick sort will be coming up with this type of the complexity. Okay, like I have given you the idea for the bubble sort. Insertion sort is also of this type of, where the pairs are used for comparing, so quadratic type of the nature. And in case of this when you have the three embedded loops, any algorithm which is having a three embedded loop, then you will find the n cube type of the complexity. Okay, order of the complexities n cube. And some other problem subsets where there are the subset problem is also there, you will see the complexity. Okay, it is 2 to the power n. Okay, it is 2 to the power n actually. And the factorial type of the complexity is also there when the algorithm that generate all permutations, when the possibility of comparison are in different combinations, then this type of the complexity comes. Okay, so this is about this complexity. If you see in the form of graphs, okay, then you will see with the values here. Actually this is the data size. Okay, this is the n value for n, and this is your function. Okay, this is your function, means exactly what is the value of the function log n for the particular value of n. This is representing the tendency in the rate of growth. So you are looking here, let's see, pick up this point. When the value is 50 of n, then the value of log n is this much only. How much? It is here somehow, somewhere, 3 point something. While in case of square root n, the value is much more. You see what is the value? This much. Not exactly, I'm just giving you the idea, whatever, wherever it will fall. It is 6 plus and it is 3 plus. So which is preferable? The log n is preferable. Okay, so I'm stopping the discussion right now here. We will go beyond for all the different possibilities and all this. I've already uploaded this presentation on the Teams. So we will complete it so that you can be able to solve the problems of asymptotic notations. Okay, so if you have any query, you can ask. I will download the attendance and then only you will leave. Okay. Yes, anyone? Sajal, Anushka, Santosh,
Yes, ma'am.
Ayush, any query?
No, ma'am.
Are you getting what I am explaining?
Yes, ma'am.
What
Yes,
we were
ma'am.
discussing actually? Okay. Santosh, what we were discussing today? This is Shashwat. Okay. What was the topic of discussion? Sajal or Shashwat? Yes. What was the topic of discussion?
Ma'am, we were
Time
discussing
complexity.
the asymptotic notations, and then we discussed about the different like log and complexities.
Standard functions.
Yes.
Then we discussed about the standard functions in the form of which we represent the complexities of different algorithms. Okay. Okay, fine. So proceed towards the extension of the topic yourself also, and then if you have some doubts, you can ask. Okay. Okay, I'm stopping it here now.